All
Welcome
right.
everybody to Triton Data Center Office Hours. This is the fourth incarnation so far. Um, so thank you everybody for attending. Really appreciate everybody joining in. Just like before, we're gonna talk about some things surrounding Triton Data Center today. We're gonna focus the beginning part on CMON, which is the container monitoring service, which provides metrics to of Triton. So you'll see it in examples of those, and it allows you to export those metrics into a Grafana to be displayed. So you can actually visualize what is going on with your Triton data center installation. So things like RAM. Uh, there's a bunch of other metrics. I don't want to explain it. I don't want to give away the fun, but yeah. So it's a really cool feature, similar to what we talked about with CNS last week. Brian will be the expert showing off some of this stuff, and I want to thank Brian again for preparing the presentation. The CNS stuff was really awesome. I'm a computer nerd myself, but I love I don't know I love getting into the little details sometimes and just seeing how things work. And with like CNS, there was a bunch of stuff that I've even worked with it for years, and I just haven't worked that closely to it. But just to see stuff that's like that is so cool. Like I get excited about stuff. So I'm sure it's going to be the same for CMON. So so thank you everybody for joining. Looks like we have a little bit of a smaller group today, which is perfectly fine. So we'll see where we end up as far as topics and discussion after the presentation. But once again, thank you for attending. Once again, this is also recorded, and this time I got it right, hopefully. So it will be uploaded and make sure I capture all the audio. I've done multiple tests. Thank you to Travis, who's also on the thing as well, for helping get us to the place where we can make sure we're OBS was a lot more complicated than I thought to get working, especially on a Mac. So thank you to Travis for that. But yeah, so I figured let's jump right into the first topic. So we're going to talk about CMON, like I said, and Brian, whenever you're ready, go ahead and start presenting, and we'll listen in.
All right. Well, I'm going to start with a Scry link, just like last time. So I put that in the chat, and you can connect to the read-only session there. Um, so, as Ravi mentioned, CMON is a service for providing metrics about Triton itself and about your instances that are running in Triton. Um, so I'm not going to go over very much of the CMON setup, um, just to say that CMON requires CNS first. So you have to configure your CNS so that the DNS names are available and whatever agent you're using to pull metrics from the CMON service needs to be able to resolve those DNS names against CNS. So usually that means having CNS be globally resolvable, or you can have your metrics agents pointed directly at the CNS server for DNS resolution. Um, and then for setting up certificates, you need to have a wildcard certificate. So it's going to be star.cmon dot whatever your CNS suffix name is. And it's best to use Triton dehydrated with that, which now that I think about it, we should have one of these sessions in the coming weeks on using Triton dehydrated because it's really cool. Um,
For sure.
so uh, once you've got CNS set up and working correctly, then you can install CMON, deploy certificates, and once you've done that, you're ready to go. So I'm going to start out using a shell script that I have that I use for debugging CMON. and anybody can download it. Let me get the link.
And just
It's in my GitHub.
for the people watching on the video, I do have. You'll see that the terminal window is being shown there. So I have the scry session um, visible there. So anything you put in there, you'll see.
Okay. All right, great. So there's the link if anybody wants to get a copy of this. But I'm going to demonstrate how to use it a little bit. So let's do CMON -H first to show some of the options. So if you have a key and certificate already, you can supply those, or it will when you do the key setup, it'll generate keys, put it in a like kind of a well-known location, and then use those. So you don't have to specify the keys every time. Um, but so let's. I'm going to do CMON -P MNX -U Triton dev. And then I'm going to do gen config first. And this will dump out a Prometheus compatible configuration. And so you can literally take that output, drop it into Prometheus, and turn it on, and it will start. It'll start collecting the metrics. So it's pretty easy to get set up. If you have like multiple data centers, multiple regions, or like multiple clouds, you can have all of them in the same Prometheus instance. Or it's often a good idea to break out, use multiple Prometheus instances, because CMON provides a lot of metrics. It's a really good idea to have your Prometheus instances on SSDs for performance, because it's a pretty particularly heavy write load. So anyway, so there's the config. I have keys generated already, but if you look at the help here, you can do CMON key setup, and it'll generate those keys for you. And that's actually just doing Triton profile CMON cert gen, I think. Yeah. So you can use that instead. This will, so what direction? I'm in my home directory here. Okay, so I'll just say yes. And then, so now CMON. And then these are the files that it created. So it creates the PEM file, or the cert.pem, key.pem, and an example Prometheus config, which is slightly different than the one that my shell script produces, which I'd like to update node Triton to be closer to the one that I produce in the shell script. But so you can take those keys, drop them into your Prometheus instance with the Prometheus config, turn it on, and it'll go. So let's do some discovery here. Oops, CMON MNX -U Triton dev. So I'm going to say discover, and then this is hitting CMON for the discovery endpoint, and it's spitting out a ton of JSON. I'm going to pipe that to the JSON command, so it's a little bit more readable. And actually, I want to less. There we go. So we've got a JSON object with a single key called containers, and that key is an array of objects. And so each object is a single VM, right? A single instance, whether it's a native zone, LX brand zone, KVM, or Beehive. And so I'm going to grab the UUID from one of these, the VM UUID. And I'm going to say metrics that UUID and pipe it to less again. And there we go. So now we've got the metrics that come out. Now, these metrics are in the open standard exposition format, which is the native format of Prometheus. So it was developed in Prometheus first and then released as an open standard. It's super easy. Every object comes with a help and a data type. So the data types can be like Boolean counters or a gauge. So Boolean is going to be 1 or 0. A counter is something that only ever goes up. Now, it can reset if the CMON agent restarts or if the zone restarts. So you'll need in your Prometheus config for doing counters, you need to tell it like large jumps still mean that it's going up. A gauge is something that has a minimum and maximum value, so it can go up and down, which is normal. So there's more info about the exposition format out on the web. I encourage you to go look at that. And I don't want to get into that exhaustively. But we can see here, so like, let's see here. So the very first line on the screen now is CPU cap metrics timer seconds. So the help says like how long it took to gather the CPU metrics, the data type it is, which is a gauge, and then the metric key name and the value. So the key name is CPU cap metrics timer seconds, and the value is 0.000 blah blah blah. Let's find one. Okay, so here's one. I'm going to put this at the top of the screen. So net ag packets in. So that's the aggregate inbound packets. The type is a counter. Now we've got the key name, and then you've got some curly braces there, and there's a list of tags. Okay, so you can have a key name that is duplicated, but then the tags are different. So in this case, like we can see, like the interface is vnix 0, nic tag external network UUID. If this instance had multiple NICs on it, then there would be this net add packets in, and you'd have one with a tag for vnix 0 and one with a tag for vnix 1. Okay. Yeah. Okay, yes, I will keep that in mind, Dan. Dan asks to specify the terminal size that I'm using, which is currently 129 by 46. So if you set yours to that, you should be able to see everything like exactly as I'm seeing it. Or if yours is larger, it'll like block off the white space around the side. So another super handy feature about CMON is groups. So let me go back to the discover. So like this first one at the top, groups is an empty array, right? So let's get that instance and Triton. Triton tag that, and then Triton CMON Groups equals demo. So I'm adding this tag to the instance, okay? And now when I do the discover, we can see that this instance has a group called demo on it, okay? And so in my discover, I can say -g demo, and now it'll only, that was way more than I expected it to be. Oh, -g demo. And now it'll only return the instances that are in that group. Okay. So in your config, gen config, let's see here. I don't have an example for it here. But so this like Triton SD configs key, you can have uh, a property in that that says like limit it to these groups. That way, so you can have a job that is only a subset of all of the instances in your account. We use that in Manta primarily because uh, the Poseidon user owns all of the Manta services, but there's too much data coming out of all of the Manta instances for a single Prometheus instance to handle. So we'll make one for doing like just web API, one for doing just storage, stuff like that. Um, but you can do this so that you have like an instance that gets like all of your DNS servers, like one that gets all of your web servers, stuff like that. You can break it out and group things in whatever way that you need to. So that allows you to um, like shard your Prometheus instances, or you can shard into different job groups. So you have different jobs with like you can have different relabel configs for a specific set of instances, or you can have a certain set of instances on a different scraping cadence. Like your backup server, you only want 5-minute metrics on instead of like 10-second metrics, which is your default. Things like that. So you can use the groups uh, to separate out um, uh, collecting like everything within a group to certain characteristics. So either by job or um, um, by like Prometheus server, like we do with Manta. Um, so um, once you have a key set up, um, you can use either this script to query CMON directly, or you can use Prometheus, or you can use any number of um, agents that are capable of reading the exposition data format. And you can use that in any kind of monitoring system that you have. Like I know like there's a plugin for Zabbix, there's a plugin for Sensu. Um, Prometheus also has remote write capability. So like if you're using InfluxDB or Graphite, which both of those are um, push metrics instead of pull metrics. Um, CMON um, CMON just exposes the metrics, and so something needs to pull those. Um, Prometheus is a pull agent, so Prometheus will pull the metrics from CMON, and then you can have CMON configured with a remote write of your InfluxDB or Graphite, which are push metric systems. So Prometheus would then push the metrics to those backend databases. Um, and then, then having your metrics in a time series database, you need to be able to visualize them. And so now I'm going to switch over to my browser and show you. There it is. Let me share my screen here.
I've closed
This
the
one.
scry window so that we can view the
Okay,
thing
yeah.
you're sharing.
So if you guys want to follow along, um, demo dot cloud. So there's the URL. There is a user demo and password demo. So you can log in and like browse around if you want to. But I've got here, let me go start at the beginning and we'll look at the data sources. So I've added these data sources to Grafana. Okay, so my Prometheus instances. And then let's go to the Explore. So in the Explore tab, I've got my data sources here. And so I'll select one and then I can search for a metric, anything. I'll say, let's see here, CFS used. That's probably not going to be that interesting. TCP open count, that might be more interesting. And now I'm going to run query and see what we get here. No, not a lot. Actually, it's just this one, which is, oh, Hound. Yeah. So Hound has quite a lot. Let's do, let's see here. No, that isn't as interesting as I thought it was. Let's just do CPU user usage. That should be, oh, come on. Oh, because it's a counter. Trying to get something that's like real bumpy. Maybe this load average. I don't know why it's not loading. Like the graph seems empty. All right. Well, I don't know what happened with my graph here, but let's go into the dashboards. So I've got a dashboard with like tons of stuff in it. So this is kind of a canned dashboard that I've created. Anybody that wants a copy of this, I can get it over to you. It's kind of like engineered towards our usage pattern, but you should be able to adapt it for whatever you'd like. So we've got variables here for the data sources. Now these are like the individual users that we have. I misspelled that one. So like these are different user accounts in Triton that I'm scraping. But you can have one Prometheus instance that's scraping multiple accounts, in which case there would be this dev or this account drop down. So you could select the account by data center, and we only have the one that we're doing right now. And then like alias, so we can drill down to, just this one instance. And we'll see, or we can select like several instances and get them all graphed together. So just going quickly over the dashboard that I've got here. So CPU utilization is going to be like basically like what you would see coming out of top. So like 100% is equal to one CPU. So if you're using like this could go up like 3, 4, 800%. That means it's consuming 800 or like eight CPUs of CPU time. CPU cap utilization is so generally like when you create an instance, you define the package for that, and you're going to have like CPU cap is 400, which means it can go to 400% CPU utilization. But the cap utilization, 400 is the top of that. And so 25% of the cap would be equal to 100% of the 400 CPU cap that it has, right? So this is a ratio of the total amount of CPU utilization that that instance is allowed. So like on this graph, if you're getting up to 100% on something, that means that you don't have enough CPU allocated to that instance, and you should probably resize it up. Some other really good ones is the time above cap, because Triton allows you to burst above your CPU cap for certain periods. And so the time above cap will show you how much time that instance is spending above its CPU cap. And I might have an example of that. If I look just at Hound. Yeah, see, so Hound is regularly spending time above the CPU cap, which would indicate to me that I should consider whether or not it needs to be resized. Now, the waiting threads graph shows me how many tasks were delayed by the scheduler because I didn't have enough available CPU cap to spend on it. And so you can see like occasionally I'm getting some, it's not that much. So last 3 hours, let's see if we go last 24 hours, what it looks like. So a little bit, not much. It's pretty spread out. So I'll probably leave it as it is. But if you have like this graph where you consistently have threads waiting, that means you're adding latency to your application because the CPU cap is not high enough for that instance. So both of these graphs are really good indicators that you should resize the instances larger. Load average is the regular load average metric that everybody's used to. Allocated DRAM, ZFS used. So we got a line for the quota amount, a line for the current utilization amount. So IO throughput. So you can use this to kind of give yourself an idea of whether this instance would be better suited being on like all SSDs or if it's okay being on spinning disks. Network traffic. So this is just like bytes in and out. We also have like packets in and out and like packet errors. You can graph both of those as well. And then I've got swap down here, like so the green line is the swap cap. And then the orange is the amount of swap that I've used. So these are just some graphs that I just happened to create. And you can look through the metrics that are provided by CMON and like graph like whatever you want. If you use this to graph your admin account or your Poseidon account, each Triton stack API instance and each Manta API instance also provides a number of application level metrics. And so there will be like the number of web requests that there were broken down by method and return code, and various kinds of errors and things like that. So those are super useful. There is in like kind of built into Triton, there is you can do like SDCADM post setup Prometheus and post setup Grafana, and it'll create a single standalone instance each of Prometheus and Grafana that are pointed at Triton itself. Um, and it has a pretty good dashboard for like Triton's own metrics. So you can use that like as a starting point for monitoring Triton itself. Um, but it's really designed being um, an open metrics endpoint that should be compatible with a very large um, list of monitoring and metric systems. So, like, while we have Prometheus and Grafana that's kind of built into Triton, and I'm showing off Prometheus and Grafana now, is by no means limited to just Prometheus and Grafana. Uh, Pretty much any metric system that you have, there should be a way to integrate this in. So um, we're not trying to be um, uh, like dogmatic about what metric systems we think people ought to be using. I know uh, if Triton comes into some enterprise, they almost certainly have a monitoring system working already. And so CMON provides a way to integrate the Triton metrics with whatever solution they already have. Um, so let's see here. I think that's about it. Um, One more thing I'll mention is that if your Triton account is an operator account, then you can also fetch the global zone metrics. So you can, like I showed you before, when it does the discovery, it'll have like containers and lists of all the instances. Um, if you do global zone discovery, then it'll have CNs and a list of all the CNs in the data center, and all the CNs have like tons of rich metrics there as well. Um, so it's a great way for monitoring your physical servers, all the compute nodes that make up your Triton data center. Um, One more thing that I just thought of is CMON has a plugin architecture. Um, so you can actually like write your own plugins. So if there's a metric that you want to get access to that CMON is not providing, you can write a plugin for that and drop it in. Um, and if that works well, and you're interested, you can contribute that to the product. Um, or if you don't feel up to writing your own, you can like file an issue and ask for like, hey, we'd like to have such and such metric in CMON. We can probably get those things added in without too much difficulty. Um, so, and I think that's about it.
We have a question in chat from Jasper. He asked, "Is
Yes.
the allowable bursting policy tweakable? Should I even want to?"
Um, n- Not really, no. So you can have uh, basically like the toggles around that are the parameters of the package. So you can put into the package like this is the CPU cap, this is the scheduler priority, um, which would be CPU cap versus CPU shares. Um, and there's also a ZFS priority, um, and those can be defined in the package. Um, and as far as how those are going to affect your instances, the best thing to do is look up in the zone config man page um, for those parameters. So it's CPU cap, CPU shares, and ZFS IO priority are the ones to look up. And it works um, exactly the way it's described in the Lumos man page.
Thank you for answering that question. Is there any other questions around CMON? And Jasper, thank you. He said answers my question. Thanks. So thank you for posing that question.
Okay.
Is there any other questions that people had? I guess not. If you do want to,
Looks
oops,
like we're good on
what
questions.
did I just do? I did something funny here to. There we go. I clicked out of the office hours video. Yeah. So if you do have questions that come up afterwards, pose them in the channel, or you can put them on IRC or things like that. Hopefully we try to get around to questions. I check Discord somewhat regularly myself. So
And if you have any other questions, like, even outside the topic too, we are here, so yeah. And like Robbie said, we were checking
Yep.
IRC in here and all that fun stuff too. So, yeah.
is there any quick topics people wanted to, like, questions, or it doesn't have to be around CMON, but things that maybe people wanted to discuss? I didn't have anything immediate, but if there's something you want to talk about, please speak now.
So I was thinking maybe it's an idea to share some basic recipes in the documentation on how to set up, for example, a very small production capable Triton setup, because some people might be interested in, well, starting out with a small solution, taking a look for themselves.
I'm curious what your definition of small is. I think it's a good idea,
Yeah.
but I'm curious what your definition of small is. I'll give you an example. I've got Kiwi Cloud in the basement. That's one head node and 3 compute nodes. And
Yeah, that's small.
Yeah, and nothing but blue giggy switches connecting everything up.
Yeah. So I think that's a pretty good definition of small, in the sense that maybe small with some redundancy, in the sense that, for example, what we did, we are also pretty small, and we have a co-located rack space with 3 beefy nodes, in the sense that, well, not on the scale probably large users are using it, but say 15K per compute node, head node, dual switch in a failover configuration, and then dual firewall in a failover configuration, and then you probably have the most basic Triton setup, which you can run in production with some fail safes.
Yeah. So the most basic one really is like the Prometheus and Grafana that come like quasi bundled with Triton itself. So you run SDCM post setup Prometheus, and then SDCM post setup Grafana. And that one's actually configured to use like UFDS for authentication to Grafana. So use your regular UFDS username password to get into that. And that's going to be monitoring only the admin account. But you could configure it to monitor others, or you can, like using that as a model, set up your own. But um, the simplest one is you run your like Triton profile CMON CertGen that'll create your certificates for you, drop them into the your current working directory, and it'll drop a Prometheus config. You take those 3 files, you put them in your Prometheus config directory, and just start it up, and it'll start monitoring that user account through CMON. And And then for Grafana, it really is like you could just like download Grafana and start it. And then you log in and add your Prometheus instance as the data source, and like there it's available. One of the things that we would like to do is take the dashboard that I showed off and add that to the Grafana like marketplace or whatever they call it, so that you could like one click, import a Triton dashboard and like it'll show up and like everything will work. There's a few things that need a little bit of like manual lining up in order to make it work, which is why we haven't done that yet. But I'd like to get all those things ironed out so that you can do that. In the meantime, you can make your own dashboards, or if you'd like to get a copy of mine, I can post that as well. And then you can like fill in the gaps in order to make the dashboard line up correctly with your Prometheus instances. Going for a more complex setup or a more high availability monitoring solution centered around Prometheus and Grafana. Now, my setup is more about performance. So what we do is we have a Prometheus instance per user account. And then we might even split that user account into multiple Prometheus instances using groups. I kind of alluded to that when I was talking about monitoring Manta, because there's all these different Manta services. When I was at Joyent and we did this, we had a Manta installation where there was like 150 web API instances. It was just like a ton of data coming in. I think I calculated it at something like 50 million metrics like per 10 seconds that we were trying to collect out of CMON. And the biggest issue there was making sure that Prometheus could keep up with it. So like having Prometheus on SSDs helps tremendously. Having your SSDs be like write optimized helps tremendously. So for the Prometheus collection part, it's a factor of your ingestion speed and how you're going to shard that out across multiple instances. And then something that may be an issue depending on your hardware capabilities is if you have multiple Prometheus instances that are on the same physical server, it might be competing for ZFS IO priority, and you might have one that is more write heavy than another, and like something's getting drowned out on IO. Like that's something that you kind of have to like suss that out yourself with your own instances and your own hardware. There's not really a way to like make a good recommendation about that, except to say that Prometheus does provide lots of metrics about itself. And we actually have here, like, here's our Triton metrics account. And so like we're monitoring the metrics of all of our instances that are doing our metrics collection. But it's like one of those like Heisenberg things where like if you're measuring it, you're changing it, right? So the load on all of our metrics collection stuff is a little bit higher because we're collecting metrics about our metrics collection stuff with our metrics collection stuff. but you can see here, for example, like the Triton dev instance right here has like some higher CPU utilization, and so like you can drill down and like see what's going on with stuff like that. And again, like time above cap, waiting threads, like those are going to show you if your Prometheus instances need to be larger. Um, DRAM allocation, like if things are running out of memory. Um, File system IO. In my experience, as long as it's jagged, then you're doing pretty good. If you're basically like flatlining on the IO metrics, then you're hitting uh, like the hardware capacity there, and you want to do something to increase the overall IO throughput that the system is capable of somehow. Um, Network traffic, like um, whatever link type you have, like if you've got a 1 gigabit link, as long as you're not flatlined on 1 gigabit, you're fine. Um, and there's a bunch of metrics that Prometheus provides about itself. If you add those things to like the Prometheus config, like you can configure a job to tell Prometheus provide metrics about yourself, and so that can be in there. And a lot of those are really handy for like determining the health of your Prometheus. So like for Prometheus, like the best thing is to shard it out. And use the metrics about Prometheus itself to figure out if you need to allocate additional capacity to that Prometheus instance, or if you need to like split that into multiple instances so that you can get more throughput on it. So the next layer is a Redis cache. And the Redis is pretty simple there. There's not really much configuration to it. These are 3 instances that we have. And so basically, like we run Redis, we do the replication config, and we run the Sentinel and tell each of them about each other. And that's about it. There's not really a lot of configuration that needs to go into Redis. And then your Grafana instances. And so we have 2. Oh wait, I forgot to mention Postgres. So we've got a triple replicated Postgres database. It's kind of the same model as Manatee, where we've got primary sync and async. But there's in this particular setup, I don't have like a Manatee sitter type agent that's going to automatically realign the roles. That's something that I would have to do manually. But like depending on like how highly available you need it to be, like that's something that you could look into. For these, like I set this up mostly for this demo, so I wasn't really particularly worried about one instance going down. I suppose if the primary had gone down during this, this office hours, we probably would have canceled it as, we've got an outage in the data center we need to deal with. But so a Prometheus instance for Grafana to use as a database instead of using SQLite. Okay, so like the default for Grafana is to use a SQLite database. Move that out to a separate database. You can use MySQL or Postgres, whatever you're familiar with. I think Grafana generally tends to encourage MySQL. I tend to prefer Postgres, which is why I set up Postgres. If you don't have a Redis cache, and I think you can also use memcached, but Grafana will cache metrics in Postgres. And while that's a little bit better than caching it straight out of Prometheus, it still can be pretty slow. Like the example that I gave at Joint, where we were, ingesting like 50 million metrics, like having Prometheus ingesting that many metrics and also trying to like query the database and return the metrics, like just like this graph here. So this is a 1 day graph, and Prometheus doesn't have like degrading resolution like InfluxDB or Graphite have. Like Graphite, you can say like I want 10-second metrics for 5 minutes, and then I want 1 minute metrics for 12 hours, and then I want 5 minute metrics for 10 days, right? Prometheus doesn't do that. Like it's whatever your scrape interval is. The scrape interval here is 10 seconds. So um, each of these lines, 86,400 seconds in a day. So each line is 8,640 data points. Okay. And so we've got 3 lines. That means we've got just this one graph. We're pulling out of Prometheus 24,000 data points. Okay. And then like here's a second graph, here's a third graph. So like each of these graphs, and I'm just looking at 3 instances right now. If there's only one metric on that graph, that it's 24,000 per metric that you're pulling, or like 8,000 per line per instance per graph, right? So 1, 2, 3, 4, like just this right here, what you can see on the page is 100,000 data points that it needs to pull out of Prometheus. Okay. And then if you look up here in the corner, we've got our refresh interval. Okay. And so like if you have an active incident going on, a lot of people are going to sit up here, refresh this every 5 seconds. And so now like we're going to be pulling 100,000 metrics out of Prometheus every 5 seconds. Okay. All while Prometheus is trying to ingest 50 million metrics at the same time, right? That puts a ton of load on Prometheus. So having a caching layer where you get all the metrics out of Prometheus the first time and you shove them all into Redis, which is going to be super fast. Then your queries into Prometheus to fetch the new data is only going to be like the last 10 to 20 seconds worth. Okay, so that's going to significantly reduce the load that's on Prometheus. That'll allow you to continue ingesting metrics at the rate that you need to. And you're only going to be fetching a very small amount of data out of Prometheus at whatever your refresh rate is, because that stuff's going to go into Redis instead. And so anything beyond the past few seconds will be in Redis. Grafana will get it from there first, so that it won't have to hit Prometheus. Having a Redis cache was like the #1 performance improvement with Grafana when we were doing it, especially if you have a large number of instances that you're working with, or your instance sizes that you're doing your monitoring with are particularly small.
And you're collecting a lot of, and you have the duration.
Well, I mean, CMON provides a ton of metrics.
Right. Well, I just meant like you have it down to like
so
10 seconds or something like that.
Right. Yeah, and I'm only looking at 3 instances, right? So if I do all, let's see here. Okay.
And just for
See how
a
many
little
I've
bit of
got.
clarification, when you were talking about that large deployment, was this SPC that you were talking about?
Yeah, this is SPC.
Okay. And
Yeah.
just wanted to
See, so now like I'm pulling 14 different instances. Okay. Or if I just say like all, okay. So I'm pulling 14 instances. And so that's 8,000 per instance, per line per graph, right? So I'm actually pulling a ton of data out of here.
Right.
And without that Redis cache, it would take several minutes for the data to load. Um, the
Which makes
Redis
it less
cache
reliable.
is yeah. You can't, like, you'd have gaps in your graph because you can't fetch all the data. Um, or you can't even really see what's going on because it takes longer to load the metrics than you have your like refresh interval set up for this page. Um, and so like having that Redis cache allowed us to visualize like millions of data points. Like we could go set this to like um, last 7 days now. I just set up these instances a couple of days ago. But now we've got instead of like um, 8,460 metrics, it's that times seven. So like 56,000 metrics per line, per graph, per instance, right? So going to a 1 week or a 2 week view when you have a lot of instances that you're looking at is so much data coming into Grafana. Um, it literally couldn't load the metrics fast enough to be displayed. Um, but having that Redis cache like turned it from like nearly unusable to instantaneous response time. Um, the Redis cache was so unbelievably fast. Like now, the um, the issue that you might have is that your browser has too many metrics that it needs to like draw the graphs for. And Grafana has plugins that you can do pre-rendered graphs. Um, so you can have those graphs rendered on your Grafana instance and sent as uh, images instead of as like vector line drawings like done by JavaScript on your client side. Um, so if you get to that level where you've got so many that it's like your browser is now what can't handle all the metrics, then you can switch Grafana to doing the pre-rendered graphs, um, and that'll help a lot. So that's kind of the progression is, you can do just like single Prometheus instance, single Grafana instance, and at some point that will fall over. Next step is like shard out your Prometheus instances, and then on the Grafana side, do an external database, and a caching layer. And Grafana supports multiple database drivers and multiple cache drivers. So like whatever you're familiar with or whatever you happen to like, Grafana probably has a plugin for that. Like I said, we use Prometheus, or we use Postgres and Redis. Um, you're not limited to those. Like if you like Memcached and MySQL, you can do those, and it should work with Grafana.
But don't use
And then
SQLite.
like at the very high end, yeah, SQLite is like you get like SQLite is just a file on disk, right?
Yeah,
So
exactly.
you once you get into where like you need to be like updating multiple rows and stuff like that, like the you get locking issues where Grafana is now spending forever waiting to be able to write something into your SQLite database that it can't get around to actually serving you graphs. Um,
So that's no
so
longer
like having
Grafana.
an external database, first of all, right?
It's just Mongo.
Yeah. So having an external database in the first place, having a cache, and then if you're on the extreme high end, um, where there's too many metrics loaded into your browser itself, and the browser can't allocate enough memory to draw the dashboards, then you can get into having pre-rendered graphs generated for your dashboards. So hopefully that answered your question well enough, and wasn't too much of an information overload. I know it's kind of a lot.
You can always go
It
back.
would be nice to have like a template of like here's what you should launch, but it's really hard to like make that in a kind of a one size fits all pattern, because there's a lot of factors that will go into it around scaling, and depending on how much you're ingesting, can really have a significant impact on how you need to scale your Prometheus and Grafana infrastructure. So, and then if you're using a different metric system, then I have no recommendations there. So you'd have to consult the vendor for whatever that is. So you're using like Sensu or Zabbix or Nagios, whatever, or proprietary metric systems. And HP has one that a company that I was working at was investigating for a while. I don't even remember what it's called, but I'm sure they have their own like scaling recommendations. So.
Well, thank you very, very much, Brian, for presenting that. It's really cool to see this. I love CMON because it's really a key essential part when you are running, even your own personal little cloud, right? To know what's being used and be able to see that at a glance.
Yeah.
To go directly into each instance and do all that kind of stuff. This is like the perfect way to do that. We're glad.
Yeah, CMON is one of my favorite features of Triton.
Yeah, for sure. I think, CNS, CMON, there's just some really cool features of Triton that it's like, they thought of this? This is awesome. Like, and when you're operating, like you just talked about, we are operating, Triton at those, the scale of SPC and stuff like that, this stuff really comes into play. So, you really got to make sure you're, oops, maybe I'll turn my, are you able to hear me better now? Sorry.
Yeah.
Okay. Yeah. I have my whole sound system, and I think my gain was turned down. But anyways, I'll make sure I adjust for that in the post. But we're coming up against the end of our time here, so appreciate everybody attending. If you do have some questions that come up, think of these stuff of, just drop it in Discord, IRC, or wherever you may find us. We'll be checking those. Like I said, we got the recording better this time, so I will be able to post this pretty soon afterwards. I'll work with Nick on getting that done, so we will have this on YouTube and maybe a few other places. So if you want to go back and there's stuff that you missed, you can look at that. So thank you, everybody. We'll see you on the next office hours. Like I said, drop questions and give us some, and also not just questions, but drop ideas of topics of stuff that you want to talk about. We'll be glad to take those suggestions. So see you on the next one. Thank you, everybody.
You guys.
Thanks.
Bye, everybody.
Bye.